Correct. I don't speak Russian. I got a friend to translate it. But I figured I would do that. So thank you and welcome to the last full-length talk of FBY for 2017. I'm Zach Kessin, and I'm an Israeli developer, and I do work and training around Elm and sometimes Erlang as well. And so that's what I want. And I want to talk to you today about Elm. So before that, I just want to tell you, thanks to the conference organizers for inviting me. My family actually comes from here. My grandfather, who's standing over on the side there, was born here in Minsk and left as a small child. So this is sort of coming home for me, and I've been blown away by the experience of being here. And this was my second great uncle. He commanded a partisans brigade in Belarus during the war. And so, so he commanded about 800, his unit had about 800 partisans in it, and they had a school and a hospital out in the forest somewhere, so I just thought I'd throw that in as a connection. So just a quick question. Who here's worked with Elm before? Show of hands. A couple people. Haskell? Java? More hands. Scala? A lot of hands, I suspect. Clojure? One or two. Other Lisps or schemes? COBOL? One hand, but I think he's joking. C#, Erlang, Elixir, Idris, Prolog, OCaml, F#. Okay. So I've been doing web development for over 20 years now. And the thing I talk about JavaScript is it lets you do a lot of stuff. Unfortunately, many of the things it allows you to do are stupid. And you go, I know what I'm doing. And unfortunately, the past tense of I know what I'm doing is, what in the world was I thinking? How did I do this? What moron wrote this code? Oh, I did. Crap. Anybody else have that experience? Yeah, a few of you. So, you know, what I want is code that has the seal of approval. And it's as correct as humanly possible. And I want to disallow as many stupid things as I can in my tooling, because bugs I find through my tooling, I'm not going to find when my customer calls me at 3 in the morning. I like that sense of security. I'm too old for 3 in the morning calls. So I discovered Elm. And I just want to tell you a bit about Elm for those of you who are not familiar with it. It's a fairly simple functional language, intellectually some descent from Haskell and OCaml and some other F# and other languages like that, that builds for building GUI web applications that compiles JavaScript. It features some of the best compiler error messages you will ever see. So I saw some Scala error messages earlier that were like this long, and it's like, oh my God. It's like 200 lines of class names. So Elm Error Messages, I won't show you in this talk, but you can come find me later, are like aimed to be really helpful about helping you actually fix the problem. You know, it doesn't give you a stack trace of the compiler, it just tells you how to fix it. It also enforces semantic versioning in the package system, and it's just generally very nice to work with. So one amazing thing about Elm is that it's quite possible to build an Elm application of 100,000 lines of code or more that will run for years on end for billions of interactions with users and never once see a runtime error. So you've probably seen JavaScript code say something like, undefined is not a function. And you're like, how did that happen? How do I fix that? I don't know. Let me spend the next 14 hours finishing at 2 in the morning fixing this problem. And then you do that, and I don't like doing that. So I want to introduce you to some of the ways that Elm can make this claim of there will be no runtime errors. So the organizing principle behind Elm is called the Elm Architecture. This has been copied by a number of other languages. I think Redux or Reactor, one of those uses it. There's a version, something similar that runs in PureScript and GHC.js, if you like that. So some of this may be familiar to you, and it's a fairly simple MVC. But the Elm architecture looks like this. Where's the laser dot on this thing? I guess this thing doesn't have a laser. Okay, never mind. So you have an update. You have that circle over there, represents the state of your application. It contains all the information about the world of your application. And you have an update function, and you get a message in that says some event has happened. The update function returns a new model and an effect that can cause external things to happen. And you have a view function that turns that into HTML. There's actually some other stuff that happens too, but we'll get to that later. So that's basically the idea. Then the view function returns to the VDOM, the virtual DOM renders it to the screen, everything is happy. So in order to do this, we start with two types. And they're generally called model and message, MSG. And in this talk, I'm going to color the model as that sort of green and the messages that sort of purple there. So this is not standard Elm highlighting. I've gone in and manually color-coded things so you can sort of spot stuff. But the model in this case is a record. And in this case, it has two fields. If you're familiar with Haskell, most of this will look fairly similar. Some of the keywords are different, but you know, an Elm maybe works just like a Haskell maybe. And then you have a message type, which is just a discrete type that can happen. So we'll start with the view function. And this is a view function. And it takes the model and uses a DSL, which is to turn it into HTML. You can see it has a function div there that creates a div. And then you can see it's got an empty list. That's attributes for the div. And then the second list is contents. And in the inner div there on line 7, you can see we have an on-click event. And it says events on-click other action, which we defined a few screens ago. Right? Sort of a meaningless example action. But presumably in real life it would be, I don't know, save my work or something like that you would actually do. And you'll notice that the other action is of the message type. So we could just have it, view is modeled to HTML. You could have done things that way. But then we have no way of telling what events can be emitted from this HTML. By parameterizing HTML over message, Elm says this block of HTML can only emit types of events of type message. With me so far? And then here I just have some code that just prints out the current time as a JavaScript timestamp. It's not that part on line 8 through 12 is not really interesting for our purposes. So what happens if we change the onClick to fake action, which I've colored brown and underscored here? Well, in this case, you'd get a compiler error. The compiler would say, I don't know what this fake action thing is. Maybe you meant other action. It will often prompt you for what it thinks a possible correct version might be. So that prevents you from ever emitting an action that your update loop doesn't know how to deal with. Now, next you have an update function. And normally it would be longer than this, but you can see we have case message of tick new time. So that's an event that's from a subscription that I'm not going to cover here, but gives you a current time. And then other action is our other action, and all right, this actually wouldn't compile because this was written in my presentation software as an example. So, but you might have, I don't know, set a flag there or something. And this is a record update syntax here. All right, does that make some degree of sense? So, also in Elm, all functions are complete functions. In many other languages, including Haskell, you can have a non-complete function. In Elm, you can't. So the case must handle all of the possible options. If we create a new event type and don't put it into our case statement, the compiler is going to tell us. So basically, you can count on the fact that when Elm code compiles, it will work. You can still have logic errors, of course. So how does Elm, what happens if you have something that would actually create an error at runtime? That should create an error at runtime. Right, we gotta be able to handle that. So we have a result type. Result is similar to either in Haskell. I am going way too fast. In that you can have either OK at a value and error at a value. But basically lets us encode how things would work when they might not. So for example, if you want to convert a string to an integer, right? Well, not all strings can convert to integers. So we use the result, and we can either get OK, 1, 2, and a number, or you can get error and a message that says, hey, we can't convert this string to an integer, right? Because, 3.1 is not an integer. You could do it, I guess it could do what JavaScript does and just take the 3 part, but that's probably not what you wanted. So we have this result type, which is, again, similar to Haskell's either. I guess Scala has a similar type. Don't actually do Scala, so I don't know. But yeah, this is just the 2 integer function. This, again, result comes up all over the place. All right. So how do we handle non-pure stuff? In Elm code, everything is pure. There are no impure functions, except for a debug log state function. There's debug log, which is impure, but except for that one function, which we'll pretend doesn't exist for our purposes, everything is pure. Well, the problem is, if you think about it, if everything in your application is pure, that makes for a pretty useless application. You can't do useful things in a only pure application, like talk to a server, or get a random number, or get your current location, or the size of the window, because these are all impure, or the time even, impure functions. So if we go back to our update loop here, you'll see we have a thing called effect, which is a command. The syntax is a command thing, which basically lets us say to the runtime, do this impure thing and come back and tell us what the result is. Okay? So if we want to make an HTTP request, we have a state machine sort of like this. We're going to issue a request to the server, and then we're going to either get OK and some value back. So if you say, give me the information on this user, you're going to get back, OK, and here's a record that says information about the user. Or you're going to get back error and then an HTTP error, which might be something like the JSON is in the wrong format, the network timed out, the URL was wrong, et cetera, et cetera. There are a couple more, but you get the picture. But you have to handle both cases. So let's look at some code of what that would look like. All right, so here's the code to generate an HTTP command. And you can see we start with a model, and we issue a command message. Now on line 8 here, we're basically encoding the model into a JSON object. There on line 8. And then here on line 12, we say, all right, we're going to do an HTTP post to the URL setup. We're going to encode that data into the JSON body. And then we're going to, this function here, which I'll come back to in a second, tells us how to decode the data we come back with. And then we're going to return with this event here, saved. So saved will come back to our event loop, and we can handle it. And then also down here on line 16, we have another function that, or it's not even a function, it's really just data, that tells us how we're going to decode our JSON. And I'm not going to go into the details of that in depth here, but basically the idea is we expect JSON to come back in a certain shape. And if the JSON comes back in the wrong shape, instead of just calling like JavaScript, JSON.parse and you get whatever you get, you can imagine if you expect your user ID to be a string and the server somehow sends back an integer, and then suddenly your entire app breaks because in one case the user ID is in the wrong format. This is just going to say, hold on, wrong format JSON, error, stop. So then our update loop, our update function would look a little bit like this, where we have the save function, which here on line 14 calls save model, which generates the command. And again here. And then you also have saved comes back with either OK value or saved error error. And then you'd set saved to true here, and you can set the error there. And you'll also notice that every branch must return a command because we're typed. So we have a command here called command.none, which does exactly what you expect it to do. But it's the command version of an empty list. It's just there to do nothing, but to keep everything type consistent. So I wanted to do show you some Elm coding. And I'm going to just rotate my laptop because I don't have eyes in the back of my head, as much as that would be useful. Yeah, I'm going to enlarge the font, don't worry. Because I imagine nobody here can actually read that. I know I can't. Yeah, but that only does it for the current buffer. OK. Can everybody see that now? All right, so let's look at this program here. This is, I was going to show you another effect, which this is, let's say you wanted to have a program, that would tell you the size of your current JavaScript window. No, it didn't actually do it. So this is Elm Reactor. It's just a little server for development with auto recompile stuff. When you compile, why am I not working? 0.0.1, 8,000. All right. We'll go with that. And you can see here that it shows the size of the current window. And you can see also that, go away. I have too many windows open. I always have too many windows open. Too many windows open is my default state of being. And you can see here that as I move it around, it changes. This is exactly what you expect. But I just want to show you how some of that works. So again, everything has to be pure here. So what's going on? Well, we have a subscription, and you see down here where it says subscriptions, right here. So on window resizes, this is an event. Send a resize event. That's the same type of message we saw earlier, but on window resize. And I can demonstrate that better. Oops. If I make all right. And you can see it again changing. Now, nice about Elm is, minimize that. Since the history, the state of the Elm world is all in one app, or is all in one data structure, we can actually replay the entire sequence of events we've seen so far. Nice thing is actually, if you've ever gotten has anyone else gotten a bug report from QA or somebody that sort of said, I did something and I'm not sure what, and now something went wrong and I can't figure it out? So with this debug mode, this is the complete state of the app, and this is the events. Normally the app would be bigger and stuff. But notice there's a button here that says export. If you click it, you get a history file, which you can then email to somebody, reload in a new browser, and safely replay. So when your QA department says, well, I don't know what I did this sequence of things, you can actually recreate exactly what they did and not have to guess. It's pretty cool. It also, by the way, works even if you've embedded your Elm code into a larger piece of JavaScript. I'm not going to demonstrate that today, but if you might have a big JavaScript app with some piece of it written in Elm. You can still do this. It still works. So I also mentioned that Elm has great error messages. So let me So let's make a mistake. And you can see, cannot find variable resize. Maybe you want the following. Or let's even be more useful. Now you see we've got a type error in that we're returning an incorrect record. So you get this complicated thing here that says, well, the type did this, this, and this. And then it says, where the type annotation says it should be model command message, but the return value shown above is this thing. Hint, the record fields do not match up. Maybe you meant this. All right, is that like not a really good error message? I mean, because you can imagine in some JavaScript code, if you had done that, you could spend hours. I mean, probably not that, but if you had maybe two modules, one says user ID, capital I, capital D, and one has user ID, capital I, lowercase d. Both of them have unit tests that are correct, but they're not, the contract between them is broken. Has anybody had that a problem like that in production or in development? How many hours did you spend debugging it? More than you cared to? Would this have been nicer? Sort of the ultimate pair program. It's just like, Also, if you add the warn function, or the warn flag, you will also notice that it told me I just added a new module there, and I don't actually use it. And it says, hey, you imported this module for no apparent reason. Maybe you want to remove that so that you don't have a bunch of modules sitting there taking up space. The Elm compiler really does its best to not just make the code correct, but to actually help you make your life easier. Because, you know, this is boring, repetitive stuff, and software is good at boring and repetitive. I'm not. I want my tools to be smarter than I am, or at least smarter in ways that I'm not. So does anybody have, that's sort of all I am terrible at estimating time for talks. So that's sort of what I have. Does anybody have any questions, would like to know more?
Yes, regarding this, the debugger, which is embedded into the Elm.
Yeah.
The ugly thing is that you have to enable this debug mode and compile the sources. So, and deploy. And that's what you are probably not doing in your productions.
This is true.
So are there any means to retrieve this, to export this log in remotely or something like that?
Not as of right now. This is new to the current version of Elm. And there are, quite frankly, a few features in it that are not in it that should be. Like, for example, I would really love it if there was a button that said, reload and rerun the history, or build set breakpoints. The other problem with it is if you turn the debugger on, it uses memory like crazy.
Sure.
For sure. So you don't necessarily want it on in production. I would put it on for QA. If you're using Elm Reactor, it's on by default there. So the answer is no, not at current. Now, since you have the complete state of your application, you can just you can create a list of that and do that. That would work. But it requires some effort. And would also require manually writing JSON encoders to serialize it.
Do you actually show the generated code?
For
All this application that you did in JavaScript, how big it is and how pretty it is?
It's pretty ugly. So now in this case, I actually had it generate HTML. Normally you would just have it make a .js file, but for demo purposes. And it is 12,000 lines or so. It's one of those things of, it's completely overkill for the type of demo you do in a talk demo, but when you start getting to 50, 100,000 lines of code, it works better. I should also tell you that version 19 of Elm, which is being worked on, includes a lot of things like pruning out unused code branches and stuff like that. And also a bunch of other features to address this issue. Normally, of course, you'd also uglify this code, uglify and compress it. And of course, if nothing else, when you compile it to JavaScript, put it on a CDN, it'll make it go faster. But yeah, it's not intended that you will actually look at this JavaScript code. The only time I ever look at this JavaScript code is doing a demo like this. It's just usually not necessary. Once in a great while.
So eventually you can have an Elm application embedded in JavaScript, right?
Yes.
Can you also reuse JavaScript within your Elm program?
No.
Not completely.
Yeah, basically the way you do that, so let's say, I'll show you another example. This is from something else. Apps, no, source, no, Elm, source, Google. So let's say you have Elm code that you wanted to send a message to Google Analytics, right? You've got some app on your web page, and you want to send an event to Google Analytics when the user does a thing, right? So what you'd use is a port. You can see it says port module up there on the top. And this generates a command that sends data out to the outside world. And then you have a JavaScript callback that listens for it. And you can also have a port that sends data in. So you can reuse data that way. What you can't do is, like in pure script, you could say, here's a JavaScript function, just call it. You can't do that because a couple reasons. First of all, it would probably be slow. Second of all, it ties the internal implementation of Elm data to JavaScript in a way that you don't necessarily want it to do. And it also just ties Elm to JavaScript. I mean, right now, Elm compiles to JavaScript. There is talk that in the future, it will compile to, say, WebAssembly. Problem is, if you've included a bunch of JavaScript, that doesn't work. It also destroys your purity guarantees because you say, OK, I can prove in the compiler that this code is all correct. Oh, but there's this JSON thing, and who the hell knows what it does? And it blows everything up. So this is how you do it. And then the flip side of that, and this is in a that's really ugly. So the flip side of that is basically you would say, you would start your Elm application like this, elmfront.im. This is the Elm application name, .embed an element. This is from flags, the data that's been being passed in, so you can initialize it with data, right? And then you'd say elmapp.ports.google Analytics subscribe, Google Analytics, and the Google Analytics function is just this. So you have a little bit of JavaScript, but it's a lot easier to convince yourself that that much JavaScript is correct, right? I'm convinced that this is correct, or this is correct, right? Or the one above it, which, they all kind of do similar types of things just for different APIs. And you actually, if you looked at the Google Analytics, there's a function command.batch where you can give it a bunch of commands and it'll do them all as a group. So you could just batch them up if you wanted to. So that's how you interface with legacy JavaScript code. But it nicely puts a nice barrier between, you have very well-defined Elm code inside, you have JavaScript code outside, and a nice wall between them. So for example, if you try to pass code data from JavaScript into Elm that doesn't have the right shape, it's like, oh, you told me you were expecting a record of this shape, but user ID is an integer and not a string or something. Then Elm will go, hold on, stop. So again, you ensure that you have that nice shape to your data, and that your data is what you want it to. Also, in the ports, here you see that, scroll up a little. Here on this line here, you can see we're passing in data. And in this case, this is a template, which is being, well, from Erlang, but that's besides the point. And you can see that line up there, var data equals whatever. So basically, it generates the initial data, in this case, in your back end, renders it as a JSON, drops it into your JavaScript, and then you just pass it in. You could do it all in one line, of course. This is just looks a little nicer. And that you could, and of course, do this from any language. This just happens to be Erlang, but you could do it from anything. Elm is completely agnostic as to what back-end technology you use. Elixir seems fairly popular, as does Go and Ruby and a few other things, and Haskell for that matter. But if you want to hook it up to a Scala backend, it should work. It's all about, it just talks JSON, so it doesn't matter. Any other questions?
Does Elm support some kind of chunking, and can we recompile that chunk we work with?
Not yet. I think that's promised in that may happen in 19. So basically, but the compiler is, in most circumstances, pretty fast. So normally the compile is single-digit seconds, at least on this laptop. And this is a 5-year-old MacBook Air, so.
Is that because it's written in Haskell?
I assume so. I could not speak. I do know that the plan is that that Evan is spending a lot of time on Elm making the compiler run faster in version 19. I don't know if the speed is exclusively because it's written in Haskell, but it is something that is being worked on, and it is in Haskell. Whether there's a causal effect in there, I have no clue. But yeah, I mean, from what I can tell, Evan thinks building a compiler in Haskell is a good idea. There was an effort, I don't know if it's still ongoing, to run the compiler in GHC.js so you could run the Elm compiler in your browser. I know that people worked on it. I don't think they ever actually succeeded. But maybe they're still playing with it. I don't know. I don't know enough about compiler internals to comment, you know.
Possible to use other protocols instead of JSON, like encoding protobuf.
There is XML. Probably. Answer is I don't know.
Okay.
I could, you know, but you can definitely use XML. You can use like URL encoded stuff. I don't know what the answer protocol buffs are, but I would be surprised if it's not there.
Does it support WebSockets?
Yes.
Via ports.
No. The way WebSockets work, I don't have an example to show you, but is basically you open up a WebSocket and then you subscribe to the WebSocket subscriptions there. So for incoming stuff, and then you use the commands to send data back. But that's how you do WebSockets. It's not a port. It's the one bad thing about Elm is that there are some parts of the Web API, like for example local storage, that are not yet supported by Elm for a number of reasons, not the least of which is many of the Web APIs, let's be honest, in JavaScript are pretty bad. You know, they're not nice APIs, and taking a bad JavaScript API and just one-for-one marry it into Elm would give you a bad Elm API. And that doesn't seem like a nice experience. So there's a feeling that we'd rather wait, you know, think about it a little more and make an API we'd really like versus it's better to have a good API we like than a shitty API we're stuck with. Some people may have a, you know, that may not be a universal opinion, but I think it's a good one.
Okay, thanks.